This is a problem from your lab, section 3.9. It says here that we have two cars moving from the same point. One travels south at 28 miles per hour and the other one goes west at 21 miles per hour. At what rate is the distance between the cars increasing 2 hours later? So imagine that this is our starting point, and then the X car goes south 28 miles per hour, and then the Y car goes west at 21 miles per hour. So it says use this diagram, and then the distance between them is going to be z, and that's going to be changing. So it looks like we can use Pythagorean's theorem, where we have z squared is equal to x squared plus y squared. And this will get us going with our implicit differentiation to find rates that are related. So we're going to differentiate this expression, the equation z squared is equal to x squared plus y squared. And when we differentiate that with respect to time, t, then each time you take the derivative of one of these functions, they're going to have, the chain rule is going to require you to take the derivative of the inside. So the first one is 2z, and then the derivative of z is going to be dz dt. And then the derivative of x squared is going to be 2x times dx dt. And then the derivative of y squared is going to be 2y times dy dt. So we want to know the distance between them, how fast it's increasing 2 hours later. So we're going to be interested in dz dt. So what we're going to do is we're going to keep this we're going to keep this right hand side. So that right hand side had a 2y here, and then we're going to divide by 2z. So that would have solved for dz dt. And once we do that, we just have to find the values 2 hours later. Let's try that again. dz dt is equal to the reciprocal of 2z, and then there's a 2y. Oh, it looks like they got rid of the 2's here, so let's be careful about what they're asking for and what we're looking for. Dividing by 2z would cancel with a couple of 2's, so let's get rid of those 2's and try again. Alright, now 2 hours later, what we want to do is how fast, where are these cars 2 hours later? So y is the one that's going west, and the one that's going west is 21 miles per hour. So 2 hours later, the car would be 42 miles away. 2 hours later, the car going 28 miles per hour south would have gone 56 if we multiply this by 2. And so we want to find the square root of 56 squared plus 42. So let's take our calculator out. I think we have a scientific calculator here. So scientific calculator, we have to go from inside out. Let's clear this. We're going to have 56 squared. Let's go 56 times 56 plus 42 times 42. So that's a total of 4,900, and we're going to take the square root of that, and that's a nice even number, or a nice rounded up number, 70. So we don't have to worry about decimals or fractions or weird square roots. And so we have z is equal to 70. So we have 1 divided by 70. And then we have x is 56 times dx dt. So the guy going south is going 28 miles per hour, so that's our dx dt. So let's go 28 here. And then the guy going 42 miles per hour, or the guy in 2 hours have traveled 42 miles. He was actually going 21 miles per hour. And then we're just going to have to work this out. So 56 times 28. And then we're going to add on 42 times 21. And so all that's going to be in parentheses, and then we're going to divide by 70. And then that's, again, a very nice number, 35. So that should be the distance or the speed at which they're going away from each other. So there's our problem.